Have you ever wanted to take raw data and turn it into something that's more visually appealing? Well, Python makes that easy using the Matplotlib library. It uses line graphs, scatter plots, and it even can handle 3D graphs as well as bar graphs, histograms, pie charts, so you can transform your data into something that's easy to use. If you want to learn more, stick around. All right, let's get started. So in this video, we're going to look at how we can take some data and convert it to some pretty nice looking charts and graphs using Python. And it's actually a lot easier than you think using a library called Matplotlib. So this isn't one of the standard install packages that come with Python when you install it initially. So first thing we're going to have to do here is to create our virtual environment. And again, we've done this before in previous videos, so go ahead and look at that if you're not sure how to do that. Then we need to, once the virtual environment is initially set up, we need to activate it. And then once it's activated, we need to install the Matplotlib library or package. Okay, so you can see the virtual environment is initially set up. So now we need to activate it. And then we need to install the Matplotlib library. Oop, pip install. Now, while that's installing, I'll actually start writing some of the code. So this is a standard convention you see with Matplotlib. Um, you'll get the specific library you're looking for within Matplotlib. There's a lot in there. And then you'll give it an alias to make it easier to use later. So we're going to install matplotlib.pyplot, and we're going to reference this as plot. So now in the code, instead of having to call it pyplot, we just can call it, PLT. So the first thing we're going to try to do here is a very simple graph. We're just going to create an instance of the plot instance to create a figure by doing, give it a variable name. We'll call it fig equals plt dot figure. And then we're going to set the parameters. So basically the size of this plot. So it's a parameter that it takes called fig size. There's other ones as well, as you can see here. But we're going to focus on this one now because it allows us to basically set the dimensions for how big or wide or tall this is going to be. And it takes a tuple, so we're going to give it 10 and 5. So that it's, basically a 2-to-1 as far as length and width. Now, the next thing we need to do is just get some examples. So with Matplotlib, one of the things it does is it takes in a list or an array of values as X values and Y values. So first thing we're going to do before we do that is we're going to create two lists, one called X values and then one called Y values. So if you remember, to create a list in Python, we use the square brackets and then we just put in our values. So let's do like 3, 1, 4, 5, and 9. And then we're going to do the same thing for the Y values. And we'll, 2, 4, 6, 8, 10. So the important thing about when we use Matplotlib with this is that the first index of the x values and the first index of the y values will coordinate with each other. So this is basically 3 comma 2 on a coordinate plane and 1 comma 4, 5 comma 6, etc. Okay, so now that we have those values, we can create our first plot. So again, we use that PLT that we created up here earlier. And it's simple as just doing dot plot. And then we pass in the x values, comma, y values. Now the next thing we need to do is just do, because this won't necessarily display it for us, but we can do plot.show. There's also plot.save or save figure if you wanted to save it to a file instead. But for now, we're going to just use a show. And then one other thing you can do before you actually plot it is you can give it some values to make it easier to read. So one of the special parameters is the x label. And this is basically what text you want to show on the x axis. So we'll just call this x values. Do the same thing for the y axis. And then we can give an actual title to it. All right, so with that, everything should be good to go. So we can just call in Python and our file name. And you can see we have our title, we have our y values, we have our x values, and we have this line graph that's drawn that corresponds with our values. So 3, 2 is our first spot, followed by 1, 4, 5, 6. Let's see. Then 5, 8, and then 9, 10. So that's pretty straightforward. But, again, this could be kind of hard to look at especially when you get further down this index where they don't necessarily line up. So what some people might do is try to save the values as a list of tuples first. So again, a tuple is just a parentheses with comma separated values in them. So first thing we're going to do is we're going to reset our x values and our y values. And now we're going to create a list of coordinates. And this is going to be, again, a list, but inside that list, it's going to take a list of tuples. So example here, we have 1, comma 1. And then another tuple, a comma separating the tuple itself, 2, comma 4. 3, comma 9. 4, comma 16. And we'll do 5, comma 25. Okay. Now, it doesn't necessarily take the tuples themselves directly, but what we can do is write a real quick program and just say let's go ahead and iterate through all the items in our coord list. So we'll call each of those an item. For each item in coord, we're going to take the x value list that we created, and we're going to append the item at the 0 index. So as we go through here, the first time we go through, item is going to be 1, 1. Then item is going to be 2, 4, and item is going to be 3, 9, etc. So item at 0 index is going to be, for this first time, 1. And then for the second time, 0 index is going to be 2. etc. We'll do the same thing for the y values, but we're going to use the item at the first index. And then once we're done with that, we're going to go ahead and plot our x values and our y values and show it again. What did I do here? Okay, so we have our first chart being displayed again, and we had an error here. Let's see what I did here. Okay, so this was a typo here. I missed a comma between this tuple and this tuple. Now let's try it again. Again, it's gonna, each time we run this, it's gonna run the first chart first. We'll close it, and then the second one will pop up, and we can see we have a line being created. Okay, so that's all great. But with a slight change, we can, so far we've just seen lines being drawn, but Matplotlib has more than just line charts. So we're going to take the whole thing here and same code. And instead of actually doing a plot, we're going to do a scatter. And I guess technically I don't need to reset these values here because the X and Y values will stay the same. So now all we're going to do is we're going to use these same values for second plot, and we're going to display it as a scatter plot instead of a line plot. Again, it's going to display our first one. Now, notice for the second one and the third one that there is no title or X or Y values because we didn't place it for those ones. And here you can kind of see that it's, it looks almost more like the smooth curve versus a line, which puts a direct line between each. Okay, so next up, what we're going to do is, you can kind of see from what I was going here, it's basically the one half of a parabola. We're squaring each of the values. So an interesting thing you can actually do with Matplotlib is instead of actually hard coding the values for like the y, you can put in a function. So for example, if we wanted to square the values, we can create our own definition or our own function for squaring and say we're going to take in a list of values. And then all we're going to do is we're going to create a result list. And then with that result list, we're going to iterate through each of the list of values and then just store the squared value inside that list. So for value in list of values, what we're going to do is we're going to take result.append, and we're going to say value times value. Or you can use the notation dot, star, star 2 to square it. And then after everything is done, we're going to return our result. Now that we have this, so we can create a new set of X values. So, and here we're just going to, go along with the parabola theme, but we'll start with the negatives as well. So we'll start with -5, comma, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. Okay, so we have our x values, but this time when we do the plot, and we'll keep it as a scatter plot, we're going to pass in the x values, but instead of actually passing in the y values, we're going to call in our square function, and we're going to pass in our x values. So what this is going to do, we have our x values as a list. We're calling this square function with that list. It's going to create a new array, a new list, and return that, and then plug it in here. And then we can do the same thing of plot.show. So again, it's going to display all the charts we've created so far. And this is a new one here. You can see it kind of creates that parabola as a scatter plot format. Now, that's all great going in and hard coding some of these values, but some of the real power for this comes in with your ability to read data from a file and then plot it. Let's say I've already gone ahead and created some random data here, 23 lines, different coordinates. You can be dealing with something with thousands and thousands of lines that you don't want to go through. But looking at this data, you can kind of get a little bit idea of what this might look like. Here you can kind of see it's a straight line, but then it kind of starts going all over the place. And you can't really visualize what this is going on by looking at it. So there's a couple libraries that can actually pull this data in and convert it automatically to a readable format from a CSV file. But that's kind of beyond the scope of this video. So we're just going to do it real quickly, create our own. And all we're going to do is just use a basic file opener. Okay, so we're going to read the file. We're going to store the content of that file. And that's f.readlines. So that'll read each line, and then that means content is going to be a list. So the 0 index, first index, second index, etc. Now, each of those are comma separated. So for each item inside that list, we can parse out. We can separate the left and the right-hand side of that comma. So we'll create another for loop here. And we'll just, call it item, I guess, again. We'll call it line because it's a line in our content. And then we're going to say our x values append. Actually, before I do that, because right now we already have x values set, we're going to reset it to an empty array. So we're going to take that line that we have. So it's going to come in as line.split. And what are we splitting on? We're splitting on the comma. And then what that does is it makes a new array for that individual line. In this case, it'll have two indexes, index 0 and index 1. So we want the 0 index. Now, this is going to come in as a string because we're reading it from a file, or it could be coming in from a string. So what we can do is make sure we convert it to an integer. And then we'll do the same thing for the y values. Except this time we'll take the first index. Now we'll do the scatter plot again. And of course, we need to show it. What did I do here? Oh, did I have a Oh, okay, so here's what I did. So it should be read lines instead of read line. All right, so now you can kind of see what this scatter plot actually looks like. We can see that line that we saw initially, but there's also all these other ones that we didn't necessarily, visualize easily. Okay, so that's great. You can actually use data from a file. What else can you do? So you can actually use random values. So let's say we wanted to go ahead and, instead of having data pre-made, we want to go ahead and create completely random values. So in order to do that, we're going to need to import the random library, which comes standard with Python. We're going to do another for loop. So we're going to do for I in range. So we're going to go from 0 to 20. So what all this means is we're going to create a variable I, and it's that I is going to iterate from 0 through 20. And then for each of those, we're going to set our X and Y values. So our X value, we're going to want to append random.rand integer between 0 and 10. And we'll do the same thing for our Y values. And of course, we need to show it. Okay, so we'll go ahead and do that real quick. So, um, I capitalize the I. And we can see our completely random data. Now, one thing I want you know, for this obviously is a splat of dots. We can't necessarily tell which one came first. And that's kind of important for determining what type of plot actually shows our data the best. Because we can do the same thing. And instead of doing a scatter, we can just do a regular plot, which will create lines, but it's going to create the lines in the order in which those coordinates are presented, which may not give the necessarily intended results. So there's not really anything of value that could probably get from this chart here. Okay, so that's all great. So one more thing on some of these charts I want to show is it doesn't necessarily need to be limited to 2D graphs. So this is one of the cool parts of using Matplotlib. We can actually take our stuff to the third dimension by adding in a Z dimension. Anything beyond that kind of gets a little bit hard. You can modify colors to try to get to like a fourth dimensional data, but it really starts to get hard to visualize after that point. So we're going to use similar to what we did here, get some random values. We're also going to add in our Z values. Now, what we need to do to enable a 3D view is we have to set an axis value equals plot.axis, and then we have to set it to a projection of 3D. And then we'll set it as a scatter 3D plot. You can also do a line 3D. So now we're going to do our plot.show. So again, we'll go through each of the instances again. And now you can actually see we can move this around and check it from different values. Now, one important thing we talked about earlier was adding in plots, adding in labels to the data. It's really important when you get to the 3D because you can't really tell, as you're going through, are we looking at the x-axis, the y-axis? So you can do plot dot title, my 3D plot, and then we can give it an X label and a Y label. And we'll do this again one more time. And then there's one last chart I want to show because up to this point, everything we've been showing has been, dealing with raw numbers, but you can actually go beyond just the numbers themselves. Right, so here you can see we have the x-axis on this side, the y-axis on this side. If we spin it around, you can accidentally have, the y-axis and x-axis without the labels actually lined up. You might get confused at exactly what you're looking for or looking at. All right, great. So the last thing I'm going to go over here is a different type of plot that you can show. So we're not just going to use lines. We're not going to use scatter plots. We're actually going to use a bar graph. So you can actually do that using plot.bar. And then we need to get some data before we do that. So you can actually use, instead of just two sets of number data, you can use categorical data. So let's say we have our data is our like a JSON object. And say we have pets that people have. How many people have pets? So we have cats. We have 10 people that have cats. We've got dogs. Well, a lot more people like dogs, so we'll say 20 or 30. And then we'll have fish. A couple people have fish, so we'll have 5. And then we'll say, I don't know, chickens. And we got one person who has chickens. Okay, so with the data, we need to basically extract out the keys and the values. So we can get the keys, which are going to be our labels for the bar graphs, as creating a list out of the data.keys. So that's going to include cats, dogs, fish, and chickens in a list. And then we also need to get the values using the same thing, creating a list out of the data.values. And that'll be 10, 35, and 1. So we'll do a plot.bar. We'll pass in the keys, pass in the values. We can set a color if we want. And then we can create our X and Y label, values. So we'll say our title is my pet bar graph. X will be type of animal. And Y is going to be how many people. All right, so we do it the same way. We just do plot.show. And you can see we have our title, we have how many people have it, we have our type of animal, and that's our bar graph. There's other stuff that you can do with this as well. You can do histograms, you can do pie charts. So we're just really scratching the surface of some of these different types of graphs and charts that you can use using Matplotlib. So hopefully this was something of value for you. If you watch this video and you're this far, give a comment below. Let me know what you liked, what you didn't like. If I was too monotone here, hey, give me a comment on that. Feedback is good. I can always try to change myself. If you really like the content, you want to see more like this, let me know. This channel is just getting started, so I appreciate anything that you can do to help me out with any feedback or some comments. If you liked it, give it a like, and feel free to subscribe because more videos like this coming in the future.
Good news, everyone.
That's right. Good news, everyone. This is Doc here. Made it to the end of the video, which means you liked it. So please click on the thumbs up below the video. If you have any comments, anything else you'd like me to see put a video together for, leave a comment, ask any questions. And of course, more videos like this are coming, so be sure to subscribe.